Hi everyone, welcome to today's session on problem solving through programming in C. I'm Rupesh Kumar. So can anyone, let's wait for a few more minutes so that everyone can join and then we'll start the session. So, hi everyone. Am I audible? Can anyone just confirm once? Just type in the chat box to confirm. Yeah, great. So, let's start today's session. Yeah. So let's start. So I'm Rupesh Kumar, and I will solve some problems for today's session. So this is the third session that we are holding for this semester. Right. So this is a session on solve problem solving through programming in C, and this is week 3, right? Problem solving through programming in C, and this is week number 3, right? And first we will go through the topics that I will be covering in this session, and then we will see some problems. I will solve some problems for you guys to help you get acquainted with the concepts covered during this week's NPTEL session for this course, right? So in this week, you all studied the following topics: operators in C, right? And what are operators, why they are useful, these time kind of questions, right? And till now, what we were doing is we were trying to build some intuition on how to solve some problems using programming in C, right? And till now, first we saw the usual the flow charts, which are very basic ways, which are graphical ways of writing a set of steps that are needed to solve a particular problem. Then we saw that we can actually convert a flow chart into a C program and ask our machine to solve that problem using that C program, right? We saw how to compile a C program and run a C program, right? And then we solved some basic problems such as if-else statements. We saw the if-else statements, how to use if-else statements in C, and what are nested if-else statements. And we were able to write a fully functional C program that can perform various tasks. For example, we did solve a problem on finding whether a year is a leap year or not using if-else construct, right? So now in this session, what we will seeing is we will be looking into the more advanced concepts, right? Like what are how to write C programs efficiently, and yeah, right. So let's start. So what are the features provided by the C programming language that will help you to get through C, right? So just a second, guys. Yeah. So let's resume. So at any step, if you feel that network is not working, right, just let me know. Right. So we start with the operators in C. So what are operators? And right. And right. So let's begin from here. Right. So what are operators? Operators, set of symbols that allows us to perform some operations, right? For example, let's say for example, so like, let's say we want to add two numbers in C, what would you would say? You want to compute sum of 2 plus 3, so what you will use? 2 plus 3. Here, 2 is your operator, right? 2 is the operator here. Plus is the operator here, and it has operands 2 and 3, right? So, classification of operators based on the number of operands. So basically, we can classify operators on based on the number of operands. So first one is unary operator, unary operators, right? Then binary operators, and then ternary operator, right? So what is the difference among these? Let's see. So unary operators. So there are two definitions that you need to focus on while seeing operators, right? So one is operator, right? What are operator? Operator are set of symbols that allow us to perform some operation. For example, addition is an operator. And the second term is operand. Operand, operand are the operand, the values on which an operator works, right? Performs on which an operator performs the operation, right? For example, in this 2 plus 3 example, plus was the operator in the above example, right? Plus was the operator, and 2 and 3 are the operands in the above example, right? So basically, plus is an operator which is operating on two operands. The first operand was 3, and the second operand was operand was 2, and the second operand was 3. So this is how operator works. So there are two basically terms that go always together in C programming. One is operator. Operator are a set of symbols that perform some operation. The symbols on which the values on which they do these operations are known as operands, right? Now, based on the number of operands, you can divide operators into three categories. Unary operators have only one operand, right? And these operators in C are basically unary increment, unary decrement operator, right? So this is plus plus and minus minus. Oh, sorry, minus minus. So these are two operators. We will see how they work, right? Then binary operators have two operands, require basically have not require, and these require two operands, right? For example, plus addition operator, for example, multiplication operator, and so on, right? These are some basic examples. There are more examples, and these require three operands. And there is a ternary operator in C, which is the syntax goes like this. We will see in future what is this. So this is condition value if condition is true. Condition evaluates to true. Value if condition evaluates to false. Right? Right. So these are three kinds of operators based on the number of operands, right? And then yeah, this is one way of classifying operators, and then other way is classification of operators based on the operation class of operations they perform, right? Perform. The first one is here is the first one would be assignment operator, right? Assignment operator is basically the equal to operator, right? Equals to operator. What it does, it the syntax is looks like this. So variable name Then you try to, is it used for assigning some values to variables? So the syntax is variable name is equals to some expression, right? Expression can be anything and terminators are required. So this semicolon is required at the end of every line in the C programming language. So this shows tells that the line has ended and this is a terminator. So left hand side is the variable where the value can be stored and value can be assigned during declaration too, right? Then, yeah, so there are various ways. What is assignment? What is declaration? These kind of things in C programming language, right? So I hope you have seen gone through the lectures. If not, I'm just reiterating. Okay, yeah, right. So let's begin with this assignment operators. Let's see how they work. So whenever we deal with variables, we need to declare them, right? Declare them and initialize them before use, right? Initialize, right? What is the meaning of these statements, right? Declare and initialize. So what you do when you declare a variable, you essentially in your C program before using any variable, what you do, you tell the compiler that I'm going to use some variable of a particular data type. So in C, how to declare variables, you use the type name and then the variable name, right? So this is the way you declare any variable in C, right? So this is a declaration, and then initialization. How do you do this? So for initialization, what you do, you use the assignment or operator, right? Variable name is equals to some value, right? Or variable name is equals to some expression that evaluates to the value, to some value, right? So these are the two ways you can initialize operators in C, right? So the thing is, you can always merge these two steps into one. You can always, so for initializing operators for assigning the value, you need to use this equals to operator. So this is a use example where we are seeing that we have to use the operator, right? We can also, so let's take an example that we'll be actually using in our program. So let's say I'm declaring variable of data type integer. So we have to always define the data type in C and then data type and then variable name. So let's say X. So for example, in your mathematics class, you must have seen problems like whenever you try to solve linear equations, you say let some problem, you say let x equals to t and y equals to 20, something like that, and you start try solving those kind of problems, right? So this is a way of using that type of construct, right, formulating those mathematical problems into this C program, right? So you declare a variable that will hold an integer value and name it x, right? Now there are two options to initialize the value. Either you first declare it and then initialize. X is using the equals to operator, right? X equals to 10, something like this. Or you can declare and initialize at the declare and initialize values at the same time, right? So you can say int x equals to 10. So both of these operations are allowed. So here we have used the equals to operator during initialization. So this shows how to declare variables in C and how to initialize the values, assign the values to the variables. And equals to operator is used for this kind of operations, right? One interesting thing about this equals to operators is the assignment operator equals to returns the value that is being assigned. So let's say you are saying int, so you have declared some variables int x, right, and y, and you are saying x equals to 10, right? And then let's say I want to store this value into some variable. So I'm saying y is equals to x equals to in 10, right? What does this mean? This means what whatever is being evaluated. So now this term on the right hand side becomes an expression and it evaluates to some value, and the value that is being evaluated is 10. Why? Because the equals to operator evaluates to the value that is being assigned. right? So the output of this is 10. So y becomes 10 here. Y becomes 10 here. So this is an interesting property of the equals to operator. It returns the value that is being assigned to the variable, right? So this was the equals to operator. Then we have arithmetic, relational, and logical operators, right? So we saw how to declare and initialize variables using assignment operator. Now we will be looking at how to use those operators to solve real world problems, right? So there are three types of operators: arithmetic, relational, and logical operators. We can use them for solving problems. The arithmetic operators are used for doing arithmetic operations such as addition, subtraction, division, multiplication, and the modulo operator, right? So these are the arithmetic operators. Let me just expand on this, right? This is addition. These arithmetic operators are binary use two operands, right? Minus is subtraction. This is division. Multiplication operator, right? Multiplication. And this is modulo operator, right? What it does, it returns the remainder, the division of operands, right? And division returns quotient or the fractional value depending upon the input, right? That we will see. So these are basic mathematical arithmetic operations. Now, first thing first. So this is very basic, very basic. We have explained these kind of operators. You can use them, but how to use them in your program, right? So let's say in a single line, you have multiple arithmetic operators, right? So for example, let's say I have this kind of line. So I say int x equals to a plus b. Let me do this. 10 plus 20 minus 30 divided by 45 multiplied by 11, right? So let's say you have this kind of operation. Then how will you compute the value of x, right? So in mathematics, you all have seen, you must have heard about the rule, Bode-Mass rule. So this is what we use in real maths to actually solve these kind of problems with multiple expressions. But in C programming language, we have defined some operator precedence table that allows us to solve these kind of expressions. So let's see, right? So let me just share a page with this. Search this shared. So if you look at this page, this is I will share the link with you guys. So this is a page that nicely depicts all the operators available in the C programming language and the operator precedence, right? So you can see, yeah, there are some additional operators that belong to C++. Let's ignore them. But others follow the same precedence rule as in C programming language, right? So this is the operator precedence table that says that how to evaluate which operation to perform first when multiple operators come in a single expression, right? So as you go from top to down, the operator precedence decreases. So basically, if the operator lies on the top of another operator in this table, then the top operation will be performed first, right? And then there is this associativity table. So which says that if there are multiple operators of having in the same line having the same precedence, for example, this unary a plus plus and a minus minus operators, then the operator to the left, so associativity tells left to right. So it tells the operator to the left have to be evaluated first in the expression if it occurs, and then the a minus minus will be evaluated, right? So this is how you can use this operation, refer to this operator precedence table to solve operations containing multiple operators, right? So for example, if you want to evaluate this expression, the operators are plus, minus, divide, multiply, right? So first what we do, step one, define the, oh sorry, share this tab. Define the operator precedence, right? So what is the precedent order? So I'm just referring to that table here. So let's see. Hmm. Yeah, so binary multiplication division comes first. So, and the associativity is left to right, right? Multiplication, division, modulo in the same line. So multiplication, division, and modulo have the same operator precedence. Then you get the binary plus and minus, right? Binary plus comma minus. Yeah, right. And then there are other operators. And we are only interested in these kind of operators in this for this expression, right? Now what we can do, we can you start evaluating our expression, right? So let's do this. So step 2, evaluate, right? So now here, for the sake of clarity, what I will be using, I will be using brackets whenever I am saying that this operator has to be performed first. I will be using bracket there, right? So I have 10 plus 20 minus 30 divided by 45 into 11, right? Now in this, in these operators, among these operators, which has the highest precedence, the operators division and multiplication have the highest precedence, and we have to determine which operator has to be performed first, right? Yeah, right. This is the sure. So yeah, so you can use this table, right? Now we know that multiplication division have the same operator precedence. So which one to use? Right here we can see multiplication, division, and remainder have the same operator precedence. So which one to use? We need to check among multiplication and division, and since they lie in the same line, they have the same precedence. Then we will check the associativity, which says left to right, right? So which operator comes left? This is the division operator. So this operator has to be performed first, and then only this multiplication will be carried out. So I'm applying brackets accordingly. So the innermost bracket has to be solved first, and then the outer bracket will be solved, right? So after this, we have addition and subtraction operators. We again, we can see that they addition and subtraction lie in the same line, so they have the same precedence, but the associativity is left to right, right? So what we do, we have to evaluate this left operator which comes first, which is addition here. So this has to be evaluated first, and then this division subtraction operation will be carried out, right? So this is how you perform this addition or solve this expression. So it becomes 10 plus 20 minus. So first you do 30 by 45. So let's take a simpler example where you can actually do the division. So let's make it 90 by 45. Right? So 90 divided by 45 is 2 here. And then what you do, you multiply this value with 11, right? Now what you solve this multiplication, because multiplication has higher precedence than other operators in this line, in this expression, right? Minus 2 into 11 is 22, right? Now what operator you have to solve first? You have to solve this plus, because it and minus, plus and minus have same precedence, but plus comes towards the left. So associativity says solve the plus addition operator first because it is on the left. So it becomes 20 plus 10, 30 minus 22. And the answer would be 8 here. So this is how you evaluate this expression. Why? Why do we need this precedence table? Because if you don't have this precedence table, this expression can have multiple answers depending upon the order you start solving these operators, right? Start applying these operators. That's why we need some unambiguous way of defining the or the way in which this expression will be unfolded, and the operator precedence table tells you to how to do this, right? So basically, I have copied the table here. So parentheses have the highest, then unary minus, then multiplication, division, modulo, then plus minus, then the relational operators, and then the comma operator, which returns the last value, right? Now this is about arithmetic operators, right? Right. Now, the next thing we are going to see is what is what do these arithmetic operators do? They can do integer arithmetic or real arithmetic, where in the integer arithmetic all the operands are integers. So then it is called an integer operator arithmetic operation. Otherwise, if the numbers are floating point values, then it is known as real arithmetic operators, right? And the modulo operator is not defined for the real operands, it's only defined for the integer operands, right? And you can always do mixed mode where the final output is real arithmetic, right? Now the next operators that are of interest are relational operators, right? What are these kind of operators? So this is one thing, typecasting here, that we'll be looking later on, but right now we should be interested in the relational operators. So relational operators are used to compare two quantities, right? So they are basically these kind of operators. Is the value. So they always return Boolean values, right? Boolean values, so which are true or false. And the operators are is greater than, right? So this is greater than operator, is less than. So this is the less than operator. Then greater than equals to, is greater than or equals to, and yeah, greater than or equals to. So you have this greater than equals to operator, and then is less than or equals to, this is less than equals to operator, right? And then this is the is equal to operator, right? Is equal to. So then there is double equal to's are used here. It's different than the assignment operator, right? Then we have this not equals to operator. Is equal to of this and not equal to, which is this operator, right? So these are relational operators that tell us about the relation between the operands on the left and the right? And they are useful for comparing values in the C programming language, right? So all of these operators return Boolean values, right? Then you have logical operators. What these do? They act as connectives. So if you have multiple, let's say if you have multiple conditions in your program, in your expression, right? So let's say your expression is equals to condition 1 and condition 2. Basically, both conditions should satisfy. Then you can use the double ampersand operator, which is logical and operation, right? Logical and. Or if you have expressions such as AXPR is equals to condition 1 or condition 2. So you can use the double OR operator, which is logical OR. Okay? So this expression returns true if, so this expression returns true when operand, both conditions are true, right? Conditions are true. These kind of operators work on Boolean values, always Boolean values, right? They work on Boolean expressions, Boolean values or expressions that evaluate to Boolean value, right? Right? Yeah. So these are logical operators. And then we have input output operators, right? So let's so yeah, everyone please just try to go through these operators again and let me know if there are some doubts. I'll be back in a minute. Yeah. So yeah, hi guys. So so logical note. So yeah, there are some doubts here. So someone is saying parenthesis has more precedence or less. So you can again go to the operator precedence table, and you can see parenthesis has more precedence than arithmetic operators, but it has less precedence than the unary plus minus operators, right? Yeah. And oh, someone is saying logical not. What is the use of logical not? Right. So, so this is not operator, which says that. So you want to say that, let's say, if you want to check if value one is not equals to value two, then you can use this not operator, right? So it says value one. You can use it like this: value one not equals to value two. For example, if you check 10 not equals to 20, 20, since it's a logical operator, it will return Boolean value and it will returns true. If you check 10 not equals to 10, it returns false because 10 is actually equals to 10, right? So this is how you can use logical not, right? Any doubt in this? Anyone? Right. So I think I have covered most of the basic constructs that you need to know to write, solve problems, math problems in C programming language. So let's start by some examples first. Right. Right. So now I'll be writing C programs and helping you out and help you to understand how to write C programs, right? Hmm. Right. Let me share the screen. Right. So yeah. So let's write basic io.cpp. So not now I what I will do, I will create some basic problems, right? I will solve some basic problems using C programs and help you to understand how to actually use these operators, right? So first file that we have created, a C source code file is, and file name is basic io.cpp. In this file, we will see how to use basic input output in C, right? Basic input output library in C for input output operations, right? So for this we need to include. So first we write the preprocessor directives that we need, that we'll be using before using our solving our problem, right? So I will using hashtag include, and I will use the stdio standard IO header file. So as stdio.h that we already saw in the previous program also, previous session also. Now what I will be doing, I will be creating my main function. So the syntax is int main. So the return type of function and the function name, which is main function, that is what any compiler expects from you, right? And then you return zero since your return type is integer. Now why return zero? It basically tells the operating system that this process has exited with value zero, right? Yeah. So now let's start with doing some basic output operation, right? So in C programming language, we have this for basic output operation, we have a printf statement, right? So we have printf statement. What it does, it allows us to print statements onto the screen, onto the standard output screen. How to use printf statement? The syntax is, so you write printf, right? And then you type in this for a plain string, right? Formatted string, basically formatted. It's a formatted string, right? And then you use the terminator here to end the line. So what you do, you print your statement, right? So how to use this? So let's print something, printf, and passing the formatted string, right? Printf, and let's print hello world, right? And then end the line. So now what you're doing, you have successfully created a C program that prints hello world onto the standard output. How to compile this? You simply use the GCC compiler, GCC, then file name is, so first you use the ls command in the Unix or Linux OS to check if the file has been created or not, right? And then what you can do, you can use the GCC command GCC and then your file name basicio.cpp. When you run this compiler on the basicio.cpp source code file, and you again check the files present in your current folder, you will find that a file named a.out has been created. Now, this is the final binary program that you can execute from the terminal. So the syntax is dot front slash and then the compile binary name. So it is a.out, right? Now you can see it is printing hello world, right? So yeah, your program was successful. You were able to write something onto the standard output, which is your terminal window here, right? So this is how you use printf statement. And now the next thing is you may want to take input. You may want to take input from the user in the term from the std in, right? Std in for now basically means basically from the terminal, right? From the terminal. So how you do that, you use scanf statements here. Right? Scanf. So scanf is used for taking the input from the standard input, right? Again, it takes formatted string here. String, which is not any string. It's not any random string, which is essentially which uses some format specifier here, right? Format specifier, and then the address to some variable where the value has to be taken into, right? So let's see how to use this and what is this format specifier stuff here and what is this ampersand, why I'm using ampersand here, right? Someone is saying my screen has frozen. Is this true? Anyone please confirm? Am I audible? Right. I hope the screen is visible, right? So let's begin. Let's resume here. Right. So let's see how to use scanf to take input from the user from the terminal, right? So for this, first you have to decide on which variable you are going to receive some value from the user, right? So let's say I am telling the user to enter their, let's say roll number in the class, whatever class they were studying. I need the user to enter their roll number in our program and use that roll number in our program, right? So for that, I will decide that I am going to use a variable of data type integer, right? So data type is integer. So now I am declaring a variable. So ask the user to enter their roll number, right? So for this, I declare an integer variable. First, I declare a variable of data type integer there to receive the value, right? So first I declare a placeholder where I'll be fill a bucket. Let's say I'm creating a bucket in which I'll be receiving some value. Then that bucket can store the values that only belong to the data type integer, right? So int roll, let's call it roll. So the first one, so first term here int is the data type, and then the variable name, which is role here, right? Anti-role and the terminator. So to end any expression, any line in C programming language, you have to use the terminator operator, right? So these all individual, so if you want to give a general name to all these kind of keywords in C, they are also known as tokens. So int is a token that defines the data type. Role is a token that is a variable name. Terminator is also a token in C, right? So we have used these tokens to write this program, and terminator is very important to end any expression in C, right? To end any line in C, sorry, any line in C, right? Right. Now we have created a bucket where we will be receiving the value. Now we need the user to fill that bucket, right? How to do that? We will be using scanf operator. What it requires you to pass in the format specifier for the value that you are going to receive. So I am going to receive a integer value. The format specifier for the integer value is %d, and then comma. In this, the second argument is the address of that variable that will be storing this value. So the variable that is going to store the value is role here. So we could have passed simply role here, but since we need the address here, so we need to use the ampersand operator here. So ampersand, which is essentially the and operator, which single and operator. It is the operator that gives you the memory allocation address in which the variable value will be stored in the main memory, right? So I have passed the memory location address for the variable rol, right? Now I end this statement. So now what I have done, I have asked in this statement, what I have ensured that I will be taking an input a value of data type integer, and the value has to be filled in the memory location of the variable role, and the memory location can be fetched by using the ampersand operator, right? I hope this is clear. Now what you can do any operations on this, right? Do do operations on variable role, right? Now let's give a first let's give a useful prompt to the user that will help them to figure out what to enter here, right? Uh, Welcome to my program, right? Then printf, enter your roll number to begin, right? Slash. Now, nice. So now what we are doing, we are actually giving a nice prompt to the user to give them the instructions using printf statement. And now we have taken the input using the scanf statement. Now let's say I want to determine if the user is eligible to vote or not, right? Let's also this is a roll number, sorry. So this is a roll number now. It doesn't have anything to do with eligibility of voting, right? So it's a roll number. So now what we do, we tell the user their roll number, right? So simply print the value that we have received, right? So what we will doing, we will be printing printf your roll number is, and again in C, whenever you're using printf and scanf statements, you have to use formatted strings. So the formatted strings can also contain integers, floating point values, strings, and other data types. For that, you need to use the format specifier for the data type, and for integer, the format specifier is %d, right? Now for this format specifier, so now once you have written this formatted string, you have to pass all the format values that these format specifiers are doing acting as a placeholder for. So there is one percentage d in this string. So you have to pass in one data of data type value integer, right? So I will pass the variable role that contains the integer value role here, right? Now your program will exit, right? This is how you take do IO and C. So again, we compile GCC basic IO dot CPP, and you will see a file a dot out will be created, and then you can run it by a dot translate a dot out. So, oh, sorry. Yeah. So now you can see the program has printed welcome to my program and enter your roll number to begin. So let's say my roll number is 1. So I will enter 1 here. And you can see the program is successfully printing your roll number is 1 here, right? So it was able to take the input and print the value, right? So someone is saying, why do we return 0 in the program? So basically, whenever you compile this C program, then it creates an executable binary that needs to be executed by the operating system. And the operating system expects some return value from the user depending upon the operating system. And Linux expects some integer value. That's why we are declaring main as an integer return type, right? Any other doubts? Anyone? Please type in the chat box. Are these printf and scanf statements clear? So these are the very basic standard IO operators that we need to learn, that you need to know before proceeding with any C program so that you can actually solve problems, right? Anyone, do you have any doubts? Yeah, someone is saying why the ampersand operator is used in scanf, right? So let me just give you a brief example explanation here why we are actually doing this. Right. So I'm just going to give you an explanation on why we are doing this, right? So yeah, I hope my screen is visible here. So I have shared my another screen. Right. So is my screen visible, everyone? Wait a minute. I think, yeah. So now my screen will be visible. Right. I hope now my screen is visible, right? So how so right now we saw that how we can do basic IO, right? Basic IO in C using printf and scanf statements, right? And scanf, right? So now we saw that we use variables to store some values, right? Variables in C store values, right? How? Like where are they storing the value? So basically there is a main memory. Right? So this is the memory where the values are stored. And whenever you write a statement like int, so this is the data type, and x, int x. So what does the C program does, or what happens in the backend? What happens is this value, a memory block of size that is required by this variable x is created in the memory, and this memory block will now store all the values that are assigned to the variable x, right? So this memory, the memory can be fetched using addresses present in the memory. So let's say this first block has this block has the starting address of 1000, right? So now all the values that you want to store into the memory in the variable x will be stored at the memory location 1000 in the memory, right? So now let's say I'm saying x equals to 10. This means you are assigning value 10 in the memory. You are putting 10 in this block in the memory. How it is happening in the backend, just ignore that. Just try to understand what is happening here. Just x, you want to store some value, integer value in the variable x. Then you create a bucket storage in the memory. You take the address of that you take you now you have some associated address of that bucket in the memory, and then when you assign a value to that variable, the value is filled at that memory in the memory in at that particular memory location, right? Now multiple questions arise here. How can we know what is the address in which the memory has to be stored? So for this we have this ampersand operator. What it does, it tells the memory address where the values are stored, right? So for example, ampersand 10 is equals to 1000, right? So ampersand 10 points to the memory location 1000. That's why this ampersand operator is here. Now, when we were doing basic input using scanf, so when we were doing scanf and you are passing a formatted string that contained an integer percentage d, right? And then the argument to this percentage d was ampersand x, right? It essentially told the program that you have to receive some value from std in and store that value into the memory location pointed by ampersand x, and that is basically this block, right? That is this memory location, and you have to fill the value in this memory location. Now, is it clear, everyone? What is this ampersand and why we are using it? Anyone? Do you have any doubts in this? Okay, fine. I believe it's clear, right? Someone is asking why we are returning zero, right? Why we are returning zero? Why returning zero? So you will learn about this when you take your OS course in future lectures, in future classes, like future semesters. So don't worry about this return zero statement for now, right? So basically, return zero is a standard. You are returning zero from your main call. So there has to be some process in the operating system that calls your function main, and basically when your main function exits, it returns zero to that process, right? That process, right? OS process. So there is something else going on at the back end. Let's just ignore that for now, right? That is not as important. Any other doubts? Anyone? Right. Someone is saying why ampersand is used only in scanf and not in printf, because in printf you simply have to get the value at that particular expression has to be evaluated, and it doesn't require any memory address location here, right? So that's why you don't use ampersand during the printf. But during scanf, you have to tell the memory location where the value has to be stored. Then you use scanf, right? Any other doubt? Fine. So I hope basic output operations are clear by now. So let's proceed from here. Right. Right. So yeah, let's proceed. Now basics are clear, right, for this week. So let's start solving the problems for this week, right? Someone is saying, can we use a void main? You can use, but it might give you error depending upon the compiler that you are using. The recorded lecture will be shared with by the NPTEL team, and someone is asking me to debug their code, so that I won't be doing right now, right? So I won't be solving this problem right now. Let me first solve the problems that I have, and then I'll be looking into those problems, right? So let's start. Let's solve few problems to give finalize the session, right? So what will be the output of the following C program, right? So we have standard hashtag include preprocessor directive and including the basic stdio header, right? And then we declare our main function. Inside the main function, I have declared a variable I here, right? So now this variable has created a location in the memory where the value can be stored. Now you can see it's a very complex example. It says if I equals to 0, 1, 0, 2, 3, printf NPTEL, else printf programming in C, and then printf backslash percentage D backslash n, and what is the value of I here, and then return 0, right? So let's start by solving this problem sequentially. So we will start go line by line and just do a dry run, what each line is doing, right? So this line inti equals inti, what it does, it creates a space, it allocates a space in the memory where values, integer values will be stored, right? So it allocates a space in the memory where integer value will be stored. Now let's go to this line. It says, let's expand it a bit. So there is some condition. So if some condition, the condition is equals to this, right? So we need to evaluate this expression and it will return true or false, right? So let's, before proceeding, so let's take this expression out, this condition out, and try to get the output of this evaluation, right? So what we are seeing here is we are seeing the comma operator here, comma operator, comma, right? Now, when you look at the C plus C operator precedence, you will see that the comma operator is here and it has the least precedence among all other operators in C, right? So the comma operator has the least precedence. Now, let's go back to our problem here. So now in this expression, we have the comma operator and the assignment operator, which is equals to here, right? So the operator precedence would be first evaluate the equals to operator and then the comma operator, right? Right. So yeah. So let's start evaluating the equals to operator. So the equals to operator, the equation says, the expression says I equals to 0, comma 2, comma 3. So the equals to operator says you need to evaluate. So you need to evaluate the expression on the right hand side first. then only assign the values to the LHS. So let's bring out the right hand side here. So right hand side is 0, 2, 3. Now how to use the comma operator, right? So the comma operator, essentially what it does is it takes it discards the value, it evaluates the expression on the left and then discards the value and returns the value on the right hand side. Right. So let's think of how to solve this expression. Now this is a expression that we have right now. So now it has three comma operators, right? And we can see here, like we can see in the operator precedence table that comma operator, when multiple comma operators appear in the same line of code, what you do, you use left to right associativity. So you evaluate the most leftmost operator, then the right one, then the right one up to rightmost, right? So let's go back. Now let's solve this. Yeah, let's see this. So now we have three operators and we have three operations here, 0, 2, 3. So we saw that we have to use left to right associativity. So we first evaluate the first comma, so 0, 2, and then evaluate the last comma operator, right? So this is how you will be evaluating this expression. And the output of comma operator is evaluate LHS, then evaluate RHS, and then return the value returned by the expression on RHS, right? So let's solve the first comma operator here, 0, 2. So the left one evaluates to 0. So LHS is 0, RHS is 2, and you have to return the RHS value, return RHS, which is equals to 2, right? So the first bracket returns 2, so it becomes 2, right? And then we had the existing comma, last comma operator, which is 3 here. Again, you have LHS expression evaluates to 2, RHS evaluates to 3, and then you return RHS, which is equals to 3. So the final output of this operator is 3, right? So now when you are trying to assign the value I, so I becomes, so now I is equals to the value evaluated by the expression on right, right? So the value we got by evaluating the right hand expression is 3. So now I becomes 3, right? So now the value stored in the variable I is value stored in the variable I is 3 now, right? Now if takes in a conditional statement here, and sorry, a condition statements here that can return either true or false. And now there is a rule that you have to remember always whenever you are trying to write C programs, that all integer values evaluate to true except for 0. So the 0 integer value evaluates to false. Other than that, all integer values evaluate to true. So let's say if I'm saying if 1, what this means? This means it is equivalent to if true, right? If I'm saying if 2, this is equivalent to saying if 1, which is equivalent to saying if true. If I'm saying if 9999, which is equivalent to saying if 2, which is equivalent to saying if 1, which is equivalent to saying if true, right? Is this clear, everyone? Now, if I say if 0, then it means if false. False, right? Only 0 evaluates to false. Other integer values evaluates to true. Is this clear, everyone? So this is the second rule that we'll be using. In the first rule, we actually evaluated the expression, right? And then after evaluation, we are returning the value on the RHS, assigning the value on the LH to the L variable on the LHS left hand side. And again, we saw that the expression inside the if statement was essentially returning an integer value. So how to evaluate any integer value into convert any integer value into conditional true or false Boolean value. So essentially all integer values except 0 evaluate to true, 0 evaluates to false, right? Now the value, again, the condition becomes I equals to 0, 2, 3. So it now becomes I equals to 3. Now, do you remember what this equals to operator returns? Anyone? Can you tell me? Anyone? Can you tell me? So let's say if I'm saying I have a variable, so let me pose this problem here. So let's say I have a variable var, so let's say integer variable, right? int and int var is equals to I, which is equals to 0 comma 2 comma 3. Can anyone tell me what will be the value stored in var here? Right? So you are right. So one student has answered. Ambika, you are right. So basically equals to returns the value that is being assigned to LHS, right? So whenever you evaluate this expression I equals to 0 comma 2 comma 3, it evaluates to I equals to 3, again due to the equals to operator. Now this returns 3, right? This essentially becomes 3. So basically this says int var equals to 3, right? Now this is applicable here. So this condition says if I equals to 0 comma 2 comma 3, it evaluates to if I equals to 3. Now I equals to 3 returns 3 here. So if 3, so it is equivalent to, so the above if statement is equivalent to if 3, right? Now we know if 3 evaluates to if true, which is equivalent to if true. So now we know how if else statements work. If the condition is true, you have to print something inside the statement. Otherwise, you print the else part, right? So you print NPTEL. So first it will be printing NPTEL. So it will be printing NPTEL. And then what you are printing here. So else part is ignored. So else block is ignored here. Now you print the value printf. And in this, you have passed the formatted string percentage %d backslash n. So the percentage d tells you that, tells the compiler that I'm going to print a value of integer data type, right? And then you have to use the backslash n, which is an escape character, which says change the line after printing this value, right? So you are printing the value stored in the variable I. I contain the value 3, right? So the correct answer is option C. Option C, NPTEL 3 will be printed. Right? Anyone, do you have any doubts in this problem? So what is the doubt? Why is 3? Why is 3, right? So again, we saw that inside the if statement, we have this expression I equals to 0, comma 2, comma 3. And we saw that how to evaluate this expression I equals to 0, comma 2, comma 3. For this, we need to understand how comma operator works. So we saw that comma operator, what it does, it evaluates the expression on the left, then evaluates the expression on right, and then returns the value of the expression on the right, right? So we use the precedence table to determine which comma to operate first. So we saw that the leftmost has to be operated first. So evaluated 0, comma 2. It evaluates 0 to 0, 2 to 2, and returns 2 here. Now again, the second one becomes 2, comma 3. Again, the LHS evaluates to 2, RHS evaluates to 3, and it returns 3. So now it becomes I equals to 3, right? The equals to operator returns the value that is being assigned. So I equals to 3 returns 3. That's why it became I equals if 3. That's why it's true. right? Is this clear, anyone? Please go through the video again and you will be able to understand this. Now, Deepika, do you have any doubts? What are your doubts? So what is the doubt? Anyone, please type in the chat box or we can proceed to the next problem. So whatever doubts you have, please type in the chat box or we can move on to the next problem. Yeah. So again, I have explained this in very detailed manner. So please go through the video again if it's not clear yet, right? So other than the concepts I use to solve this problem and interpret the output of this program, other than the concepts that I have covered till now, do you have any doubts? Because I have explained this answer in a very detailed manner. So please go through the video again and you will be able to understand, right? Yeah. So I don't feel any other doubts in this domain. So let's move on to the next question. Someone is saying what are the escape sequences, right? So escape sequences tell the compiler that you have to add some escape sequence after this line. So backslash n is for changing the line. It tells the compiler just simply change the line after this character. That's it. How they are defined and how they work during the compile time is the different question that we will not be covering in this session, right? Right. So let's move on to the next question. What is the output of C program given below? Right. Right. So again, we have this usual function in our program file, and we have standard header library, right? And then int x equals to 0, which says integer variable x equals to 0, right? So we are essentially creating a memory location and storing a integer value 0 in that location. Right? Store 0 in the memory is the variable x, right? So now this, yeah. Now if x plus plus printf true, else if x equals to 1, printf false, return 0, right? Right. So I hope you have seen this video lectures on unary operators, right? So it requires what are the concepts required here? Unary operators, right? Then if else statements, and the third one is simple conditional checks, right? Conditional operators, right? So what is the equal to, right? So among these, I haven't covered unary till now. If else and conditionals are clear. So let's look into this. So this line says if x plus plus, right? So it says if x plus plus. So how to interpret the conditional being used here, right? The Boolean value being used here. So x plus plus, here we can see x plus plus. So what is this? This is a unary operation. The operator here is plus plus, which is postfix increment because it comes after the operator, right? So what does the operator do? It essentially increases the value of integer x by 1, right? So, but after using the value of x at this occurrence, right? Basically, this is what this unary x plus postfix increment does. So whenever in the expression you observe this postfix increment, what it does, it tells the compiler to use the value present in the character at this location, at this position. And then after you have used that value at this position, increment the value of operator x in the memory, right? So what this evaluates to, so x, the value of x was 0 here. So it use the value 0 for x in this location in the expression, then increment it to 1, right? Right. Wait, right. So you use the value and then increment it to 1, right? So now the value is 0. So we all know that 0 evaluates to false in the Boolean. 0 evaluates to the false value, false Boolean value. So it says if false, right? It is equivalent to saying if false. If false, then don't execute this, right? You go to the else part, and then in the else part you have if x equals to 1. So now this is again in so inside the else block you have another if statement, right? So if the first statement, if part was, if block was false, then what you do, you go to the if else block and execute whatever is present in the else block. Now else block has another if statement here, right? Now here what you have to check, if the value of x is 1, right? So earlier, before this occurrence, value of x was 0. Now it has become 1. Why 1? Because there was a unary operator here. It is 1. Why 1? Because we had postfix increment here. So which incremented the value to 1 here, right? So in this line, x was 0. In this line, x was 0. From this line onwards, it became 1, right? So it became, x became 1 from this line, right? So if x equals to 1, so this is true, right? If x equals, wait a minute, yeah, it says, yeah, if x is equals to 1, so it checks if the value stored in x variable is 1, then what you have to do, print, you have to print false and then return 0. So it returns false here, right? Option. Anyone, do you have any doubts in this problem? Anyone? So Boolean is basically a data type that allows you to store true or false values. Boolean data type to store true or false values. Let's see, right? Right. Any other doubts in this program? It's very basic program, so it helps you to understand the use case of postfix increment and double equals to operator. Any other doubt in this problem? Anyone? Fine. So let's move on to the next question. Hmm. What is the output of the following C program? Right. Again, you have included standard IO and INT main function. Now I'm declaring a variable X, and then I'm saying X equals to 10 equals to 20, not equals to 30, right? This is an expression evaluation problem. And in the next line, I'm printing the integer value stored in the variable X here, right? Return 0, right? So only thing we have to figure out in this program is what will be the output of this expression evaluation. So let's take out this expression and try to solve this. So the step one, we all know operators present in this. So the operators are assignment equals to, then double equals to operator, which is a comparator, right? Comparator, it checks if they are equal or not, then not equals to, again, another comparator, right? Right. So to evaluate these expressions, what we need to do first, we need to determine the operator precedence, right? Precedence. So again, let's go to the operator precedence table, right? So now, let's see. So the relational operator equals to, double equals to, and not equals to, they have left to right associativity. So left one has a higher precedence in the expression. Then equals to, which is simple assignment operator, has the lesser precedence than these relational operators, right? So first you have to evaluate this relational operators, and then you evaluate the simple assignment operator, right? So now we have determined the operator precedence. So first evaluate double equals to and not equals to. Again, this in this order. Since double equals to occurs left, so first evaluate double equals to, then evaluate not equals to, and then evaluate equals to, right? So let's try to figure out the missing blocks here. So double equals to includes this operation, right? So what is the output of this? This returns false, right? Everyone, is this clear? Right? 10 double equals to 20 returns true. Sorry, this is true, right? 10 is not equals to, oh, sorry. Anyone, can you tell me what will the output here? Will it return true or false? Right? It returns false because 10 is not equals to 20. Then we have resolved half part of our problem, 1/3 of our problem. So we have resolved the first operator with the highest precedence. 10 double equals to 20 returns false, right? So it returns, again, what does false mean in integer values? Anyone? 0, right? So integer false means 0. Now again, 0 not equals to 30. Is this true or not? It returns true, right? Which is 1, right? So now, so your expression becomes x equals to 1 here, right? Is this clear, everyone? How I have evaluated this expression and what will be the output printed by this program? Anyone do you have any doubts? Please raise your type in the chat box. Is this expression evaluation clear? Right. So here we saw how we deal with these kind of operators to solve the problems. The option is, answer is option D, right? Right, everyone, is this clear? Fine. So yeah, now we have some C programming language problems, right? So let's take this. It's already more than 1.5 hours in our session. So we have approximately 20 minutes left. So I would like to take problems from you guys. So please type in the chat box if you have any doubts. If you don't have any doubts, then I will be proceeding with solving another problem, right? So till then, please start typing your queries in the chat box and I will be addressing them one by one. So yeah, everyone. So let me take few of the doubts that you have, right? Right. So someone is asking, this is a question not in C, but it's related. Binary is 1 0, ternary is 1 0 minus 1, mainly 0. I'm not sure what to explain, but yeah, I can tell you how binary came from is basically 0 is a state of low voltage and 1 is a state of higher voltage. Just think of it like that. So these are just two states, 0 and 1. That's it. That's how binary came into existence, right? Right. Right. So I think no, there are no other doubts. So let me again solve another problem for you guys. So write a program to print hello world without using semicolon. Right. So let's solve this problem. So we all know that this semicolon is basically the terminator character, right? So terminator is required to end all expressions in C, right? So how can we write something? How can we write, right? So we can try printf and hello world, right? But again, it will require this terminator here. So let me give you a way to do this. Right. So let me create a new file, hello world.cpp. Let me include the hashtag io stdio.h np main return 0, right? So one way would be using printf statement, printf hello world. But again, this is wrong because we needed to use this terminator here. Let's use a trick here from the if statement, right? So if statement allows you to evaluate, use any expression that returns some integer value or boolean value, right? So if you write if printf, right, hello world here, right, and just do nothing, right? So now this program essentially contains no terminators, right? Let me make this a void main function here. So I'm not returning anything also from this program. Now I think this should work. Oh shit, you can't do this. Yeah. Yeah, you can do this actually. Yeah, you can do this, right? So you can have int main and you don't return anything from your program. And technically you can write this function that prints hello world without using any terminator. Right? And then run a dot out and you can say it prints hello world here. Again, in defining this, there's a nice idea of trying to use a macro. Again, in the macro, you have to use the terminator. So in this program, anywhere you don't use the terminator here, right? Any doubts in this program, anyone? It's a neat trick where you can use printf. It's nothing, it does not have any logical use case here, but yeah, it's just something that you can do using C. Right? Any doubts in this? Anyone? Right. So this was one example. So right? Again, another problem. Right. So another problem, what will be the output of this program? Right. Let's solve this. We are including the standard header library and then int main inside the main function. I am declaring and initializing uh, two variables here. Again, we got to see the use of comma operator here. Right. What it does, it tells you to evaluate the expression on the left. So basically assign the value of 0 to variable A and assign the value of 10 to variable B. Right. So now A contains A is 0 and B is 10 here. It's not exactly is, it says it contains, right? Then in this line, you are saying if A equals to 0, A equals to 0. So just check here, it is not double equals to, right? Not double equals to operator. It's not the comparator operator, it's simple assignment operator. So what it does, it assigns the value 0 to variable A and returns that assigned value. So it essentially is equivalent to saying if 0, right? So is it true if 0? Now 0 evaluates to false in Boolean. So it says if false. So it is again equivalent to if false, right? So you don't evaluate this since it's false. So you print the evaluate the false part, other part, right? So you print false here. So it will print the output will be false, right? Is this clear, everyone? Do you have any doubts? So if you have any doubts, please type in the chat box. Yeah, again, in this problem, you say, I have declared a variable A, assigned a value 0 to this, and I have variable B and assigned the value 10 to this, right? So A contains value 0 and B contains the value 10. Now, I'm saying if A equals to 0, so just mind here it that this is equals to assignment operator, not comparator operator, right? So what it says assign the value 0 to the variable A and return that value. So it becomes if 0 and now 0 evaluates to false in C, right? 0 integer evaluates to false. So it says if false. So if it's false, then what you do? You ignore the block inside the if statement here and you execute the block in rest of the block. Now there is a else statement here. So whatever is present in the else statement will be executed and it prints false here, right? So you can simply see that it will output false here. Now is this clear, everyone? Everyone, is this clear? Right. So yeah, so that's it. Always solving the remaining problems in the next session because there is not enough time left in this session. So if you have any doubts, please type in the chat box.